The platform is all yours.
Thank you. Thank you, ma'am. So, good evening, everybody. Thank you for waiting for me. I had some personal problem today. That's why I had to postpone it for a few hours. Okay, all right. So, before I start my presentation, I would like to ask all the students, like, which language would you prefer me to speak? Do you want me to speak in Nepali, or do you want me to continue in English?
Sir, I think they have
Japanese, sir, Japanese.
pretty good Nepali and Nepali.
Okay. All right. So, if you have any trouble understanding what I would say, because I might use some technical words, and if you have any problem understanding those, you can just maybe raise your hand. Or you can ask questions even between my presentation. I don't have any problem with that. Okay. So if you have any problem, just raise your hand. You can raise your hand in the Zoom, and then I will try to answer the questions. Okay. All right. So I want to start my presentation here. Let me see. Okay. Yeah, I'm going to share this. Okay, here we go. All right. So I'm sharing all my screen. I will do that. All right. So today I'm going to talk about a little about the space-based tools for monitoring disasters in Nepal. Space-based or ground-based. So I'm going to focus a little bit more on the space-based tools for monitoring disasters in Nepal. I've been working in these monitoring disasters before I went to Japan. I went to Japan in 2013 for my further studies. Before that, I used to work in this. I worked for the landslide monitoring and the landslide susceptibility. And then when I went to Japan in 2013, I started working in earthquake engineering. Okay. So let's go. So this is my little introduction. Ma'am has given the introduction. My name is Subeg Bijukchhen. I'm a research and development coordinator in Khowpa Engineering College. And my education background, I did my PhD in strong motion seismology. Now, it might be a new term for many of our students. Strong motion seismology means it's obviously the study of earthquake, but larger earthquakes. So the earthquakes that affect our buildings, like the small earthquakes, the one which occurred a few days ago. I'm not sure how many of you were awake in the morning. It was around 6 a.m. I think. So not that kind of earthquake, because they don't affect our buildings. Okay. So my subject or my expertise, let's say, is in the strong motion seismology. That means larger earthquakes, larger than 6.5 magnitude earthquakes that affect our building. And I study those earthquakes. And I did from Hokkaido University in Japan in 2018. Before that, I did my master's in engineering in seismology from the same university in 2015. And before I went to Japan in 2013, I did my master's in science, MSc in engineering geology from Tribhuvan University. And before that, I was BSc in geology at Richanda campus. That's where I met Rijendra. So it's been 15 long years. I've known him. He's a good friend of mine. Okay, and my research interest, I work in seismology, earthquake engineering, and disaster mitigation, landslide and earthquakes. I haven't worked much in flood. Mostly in Nepal, we have three main types of disasters: flood, landslide, and obviously earthquake. Of course, there are other as well, like for, let's say, the winds, like the storms, but those three are the most the main natural disasters we talk about. And then, of course, engineering geology, and then remote sensing. I used to work in a remote sensing in landslide before I changed my expertise to seismology or earthquake engineering. Okay, that's all about me. And the background you can see is the Khowpa Engineering College, where I'm currently working. Okay, so let's go. So what I'm going to talk about today is I'm going to talk a little about tectonics of the Nepal Himalaya. I hope many of you have already studied a little about tectonics, or what is tectonics, and how Nepal Himalaya is formed. If not, then it's okay. We're going to talk about it. And I'm going to talk about the space-based data or ground-based data, a little about that, not much, because you might know a lot about it. But if you want to know more, we can discuss that later. And I'll talk about landslide monitoring using those kind of data. And then we'll talk about how floods are being monitored, and then how we monitor the earthquake. Okay. Okay, let's go. So first, let me tell you how Himalayas are formed. And maybe all of us know that Himalaya is the product of collision between the Indian and Eurasian plate. Now, that plate means tectonic plate. Our crust, you know, that crust, mantle, and core of Earth, the crust is divided into many plates, and they are moving. Okay, they're moving every time. Like, not one of them is stable. They're moving. So I don't want to go into like why they move. There are different mechanisms, physical and geodetic. We call it geodetic. That means related to the Earth. I don't want to open that can of worms now. If we have a chance, I will talk about it in some other day. But just let me tell you that these tectonic plates, they move, okay? They go apart from each other. They come together at some point and they rift apart. Like, for example, this Africa in the center part, it's being rifting now, just like this. This part, tiny part, is Madagascar. Maybe you have known that from the cartoon. So Madagascar. And India was somewhere below the equator at some time in the past. And then it slowly, gradually moved to the north. And then it collided with the Eurasian plate. The Eurasian plate, this green one, is a huge one, and India is a small one, and it collided. But the collision is not sudden. Like, it took more than 20 million years. That means 2 crore years to complete. Like, it here, this is very fast animation, right? So it started colliding on 65 million years before today. That means 6.5 crore years, and the completed collision around 45 million years. So it took about 20 million years to collide, like start and then collide. Okay. So what did this? When this collision happened, what happened was, like, for example, this is the French art is about the French art. It's about from the Lefort, is a scientist, a French scientist who studied a lot about geology and tectonics in Nepal. So this is from the Lefort. So what he did was here, it's a sketch here. So it's called Petite Inde. That means petite means it's a small car. I don't know how many of you have seen that Mr. Bean. He has a small car, right? If you remember that. Okay, that's a small car. It's called Petite means the car's name. Petite, small. Petite Inde, and then Large Convoy Asiatique. That means the large convoy Asia. And when they collide, la collision, and then it gets folded, and it gets fractured. So many things happen there. When you look at it, it kind of looks like fold. Okay, so this is the Himalaya, this is the Tibetan plateau, and then the effect was much on the northern side as well. Okay, but the Indian plate was really crushed. I'll tell you how. So let's say this is India, huge landmass. It was moving on the north, and okay, and where our country used to be in the past, there was a sea, and we call that Tethys Sea. Okay, it was the Tethys Sea, and then gradually, when India collided with the Eurasian plate, at the area beneath the sea, it slowly rose up. Okay, so if you want to take an example, what you do is that you take a piece of paper, and then you hit it like slowly on the wall, or let's say with the hand. This is the Asian plate, and this is the Indian plate. When you bring it together, it cannot go for the nerves, so it just rises up. It's very similar to that. Okay, it's a very slow process, but it happens. Okay, for example, this went inside, and this whole area slowly rose up, and this rising is still going on. That's why you might hear that people say, like, the height of Mount Everest has increased from 8,848 to 8,850 meter. So this kind of things happen because our whole Himalayan region, it's uplifting. Okay. So let's say, okay, here it collided, and then the Himalayas formed. Okay. And then when it collided, though it's a very slow process, but it's a very huge process. That's why this whole area gets crumpled, it got folded, it got fractured. Okay. And then it kind of pinched out those whole areas, like, okay. So this area, the Himalayan region, we call it Young Fold Mountains. Okay, so Young because it's still rising. For example, if you compare that with the Alps in the Europe, like for example in Switzerland, that's where they have the mountains. They call it Alps. The name is Alps. That's where the word alpine came from. Alpine means mountainous, right? It came from the word Alps. And there's the Rocky Mountains in the United States. There's Pyrenees in the Spain. There are many mountain chains in the world, but this one is the new one. The Himalaya is the new one because it's still rising, and while it's rising due to the collision, so it's also fragile. Okay, the rocks are not stable, and we get a lot of landslides. We get earthquakes because it's really dynamic. Okay, so we call that young fold mountains. Now, why are they called fold mountains? Because do you remember, like, how many of you don't like to make your bed in the morning? Like, for example, the quilt, the blanket, you just like leave it on the side. Okay, so when you push it aside to the wall, it kind of makes this kind of structure, right? Folded, and some places go up, some get down. Our mountain is very similar. The Himalayan region is very, very similar. Okay, on a very large scale, though. Exactly this. So that's why we call it fold mountains. There you have mountains, there you have valleys where the rivers flow. Okay. That's why it looks like this. This is a satellite image. And of course, it's a little manipulated to reduce the cloud cover and all that. So these are the main rivers. If you have heard about the Indus River, we call it Sindhu in Nepali, Hindi, and Urdu. Sindhu River is here. This is Ganges or Ganga. And then here somewhere comes it's called Shangpo River in Tibet. And somewhere it flows through Lhasa. And when it comes to India, it's named as Brahmaputra. And when it reaches Bangladesh, it's called Padma. It's the same river, okay? The Ganga and Padma, they join at Bangladesh. So why do rivers flow from here? Because this whole Indian plate is pushing north side. And then here we have the South Eurasian plate, and then this whole area is crumpled. Okay, the folded mountains. You can see this is a Himalayas, Mount Everest is somewhere here. This is the Tibetan plateau, and I don't know if you can see. This is the green part is the low-lying area or the valley of Ganga, Gangetic, Indo-Gangetic plain, or simply Tarai here. And then this whole area rises up, and then it forms the Tibetan plateau part. Here's the Himalaya, and somewhere here. Kathmandu Valley is somewhere here. Okay. So you can see how it pinches very, very similar to this figure. Okay, it pinches out from here in Afghanistan even to Burma. Okay. So what happens is that when this happens, when this part went inside the Indian plate, it went under the Asian plate. This area got uplifted, and then if you remember physics, there are two kinds of deformation. One is brittle and one is ductile. Now, what is brittle is that take a chocolate bar and try to break it. It breaks cleanly apart. Now, that's brittle. If you heat it a little, for example, put it in your hand for a bit, and then it becomes softer. And if you bend it, you can bend it a little. Now, that's ductile. So both kinds of deformation happens here. If it is very much deep here, it will undergo the ductile deformation due to the heat and pressure. And then if it's not in the surface, it's very brittle. Okay, so it's very brittle. Now what happens is that these are the typical rocks or the mountain side of Nepal. If you see, this one is the figure. This is my photo. I took that photo from the Siddhartha Highway. If you have heard about it, it joins the Butual, Palva, and Pokhara. So this is a few kilometers north from Butual, and there's a river down here. It's the Tinau River, and this is the right bank because the river flows from this bank to here. So this is on the right side of the river. So typically, you can see the rocks are breaking apart. There's a thick rock bed and then small bed, thick, small, thick, small. It's kind of fragile. So I don't have to give an example, you know. Okay, this is very fragile. Why it is fragile? Because it's very dynamic. It's moving up. There's a brittle deformation going on. We are rising up, and then there's a continued force going on. We are having earthquakes. We're having landslides. Okay, there are other reasons of landslides as well, but this is one of the reasons. It's a fragile geology. Okay, you know. Okay, this is the Mughling Narangad Highway, and it's giving problem this year again. Okay, so this is a stress map, like the people, what the people have done is that the researchers, they put some stations here, like it's a GPS station. They monitor how the whole crust is moving. They found out that the Indian plate is still going north, and that this part is moving a little south, just like this figure. And I'll go back again. It's going south, it's still north. And they found out that still the movement is going on, and this whole part is rising up. Okay. So here it is. Now, we also have alerts of earthquakes, as you know. Why there's a lot of earthquake? Because this is, let's say, this is an Indian plate. I will just move it here. Okay. And don't go about this interseismic, post-seismic. We don't need that. Just focus in here. For example, if I cut the area, this is south and this is north. This line, this ductile shear, below that is the Indian plate, and the Indian plate is going under the Eurasian plate, because the Eurasian plate is very big. It doesn't allow it to go up, so it'll go down. Okay, and here there's a ductile shear, ductile, brittle, and ductile shear. The energy is stored here because it's not smooth. The Indian plate doesn't smoothly go under. If it's smooth, we would not have any earthquake, but it's not smooth because try to force, like try to move two rocks, let's say rocks, let's say brick, take two bricks and then try to slide each other or slide past each other. So there's a friction. You can't do that easily, right? And if you force it more, you might get the chunks out of it. You might break that even, okay? Very similar things happen here. We have lock zone, means the rocks here, they don't allow smooth movement of those plates. So the energy gets stored there. This is continually moving north, as we saw here. Okay, so here it's continually moving north, but this area it doesn't allow. The rocks, they don't allow it to move north. So the energy is stored here, and the energy, as we call stress, okay, that's force of an area, if you know, stress of force, and it gets stored. And then when the stored energy is more than the strength of that rock will break, and then it will move a little, and then it causes the earthquake. So this is happening in our country every day. You might not feel the earthquakes, but we are having a lot of earthquakes. Every dot there is an earthquake. Okay, so this was for 10 years, 1994 to 2014. Before that Gorkha earthquake, we have a lot more earthquakes after 2015 Gorkha earthquake. Okay, but even before that, we have many earthquakes. So some earthquakes are clustered here, some are here. Okay, so Kathmandu is here, and we have earthquakes in the western part. We still get earthquake if you listen to the news. If you read the news, you might hear that we have earthquakes in Bajang, Bazura, and Jajarkot area, and also Sindhu Balchok area. That's after 2015. Okay, so this is before 2015. We still have a lot of earthquakes. We get earthquakes every day. The thing is, we don't feel earthquakes that they are smaller than 5. Okay, if it's very near, we might feel. Otherwise, we don't feel. These are all, some earthquakes are very small. We call them instrumental earthquakes. Now, instrumental earthquakes means the earthquakes that can only be detected by instrument, or the instrument, we call it seismometer, that detects the earthquakes. So people cannot detect that. Very small. Those are called instrumental earthquakes. So there are many earthquakes going on even now. Okay. So what I was gonna tell you that due to the fragile geology, the tectonics, we have a very fragile kind of mountains. Okay. So we get landslides, we get earthquakes. Okay. And you might have seen the roads. We make road, and then we get landslides every year. Okay. Okay. So now, after that, if you have any questions, you can ask here. Okay. This might be a little overwhelming to you. Okay. So what we know about space-based data and ground-based data? First, we talk about satellites. Okay. So we're talking about satellites. We have Earth observation satellites. Okay, so let's say Landsat by US, it's called, they named it Landsat, or GOES, that's a weather satellite of the United States. And we have Sentinel satellites, the sport satellites of France, and more. They can find those data of satellites from NASA Earth Observatory, NASA is a website here, or even Earth Explorer by United States Geological Survey, and many more. I just give an example of two. For example, let's see, these are a few of I took the space from the Wikipedia. So these are some active satellites that are orbiting our Earth so that we can study about various aspects of Earth. For example, the Aqua, it is a NASA satellite, and it studies about the oceans and atmosphere. Okay. And we have Aura, like Calypso, for example. I talked about GOES, GOES, that monitors the weather from the Weather Agency of United States. And we have Landsat 7 and 8. There were like 1, 2, 3, 4, 5, 6, 7, 8. 1 to 6 is already out of order. Means they don't work anymore. Now we are using 7 and 8 in the United States. And they also have from European Space Agency, Proba, Source, Terra. There are many of those. Okay, these are very few of the Earth observing satellites like we observe. And everything has a different, let's say, a different purpose. For example, global precipitation measurement satellites. It studies the global precipitation, and this was jointly hosted by NASA, United States, and JAXA, that's the Space Agency of Japan. Okay, so JASON is seen as means Chinese and American. Continue JASON 3. It uses the radar altimeter to monitor the ocean surface height, because you know due to global warming, the ocean is rising. Okay, so it monitors that like that. Okay, if you have time, you can just go to this. I'll provide you the PDF of this presentation. You can just go to this website and then check about that. Okay. So another thing I want to tell you about the global, it was first used by the American military to exactly know your position on Earth. Like for example, how would you know where you are in Earth? You need something. Or for example, if I'm in my home, I say like, where do you live? And I say, I live some meters, like some 100 meters north of a pond or a lake or a school, like that. Okay. So what does GPS do is that they have the satellites, they are orbiting the Earth. Okay, they have 24 satellites, the GPS, and they are all orbiting the Earth. And we have some handheld devices. You can also use your GPS in your phone, or you have some handheld devices. You can use it in your car, and then it gets the signal from those satellites, and then the satellite, and then it goes back to the satellite. So what does the satellite do is that it monitors like how much time does it take for the signal to go from the satellite to the handheld device and then back again. So what it can do is that it can calculate the distance. Okay, so use 2 or 3 satellites, and then it can pinpoint your direction. It will give you latitude and longitude of where you are, and even altitude. Okay, so GPS, Global Positioning System, was later commissioned to use for the general public by the United States. It was a military equipment first, and then it gave back to the civilian. And then after that, EU also had the Galileo positioning system, and then the Peto in China. And GLONASS is Russian, NAVIC is Indian, and Michibiki is Japanese. So there are many of those. Okay, so if you have a new smartphone, possibly if you download the GPS app there, and then you can choose like which of the global positioning systems, or the we call this navigation system. Okay, you can choose which one do you want to use. Do you want to use Galileo as well as GPS, or if you buy a Chinese phone, you can use Peto, or if you can use GLONASS, the Russian, or NAVIC and Michibiki also. Okay. So what does it do is that it tells you where you are on the Earth. Okay, very accurately. Okay. All right. So it's a kind of ground data. Okay. So I'm showing you the satellite image of Kathmandu Valley. So this is the photograph taken from a satellite. It's so I'll provide you the satellite, the figure as well. You can find it in the NASA Earth Observatory. It is a really, how to say, very high resolution image. Now, what is a resolution? Okay, so I'm going to tell you about spatial and temporal resolution. Spatial temporal means about space, not about the ground and space, but about the space in 2D right here. If I zoom it, For example, if I zoom the photograph, as you have done, I think you have done that, you can see the pixels at last, like at the square, okay, the pixel. So the size of the pixel is the resolution. For example, if I zoom too much in this figure, and then I start to see the pixels, like the squares in the figure, and if the size of that square, one square in real world is 15 meter, then the resolution of that image is 15 meter. That means that's the smallest, how to say, the smallest scale we can measure from that photograph or that image, okay? But if you have a very good image, you can have, like, for example, 2 meter of resolution. That means the smallest point is 2 meter. It's a very detailed map, okay? So I think this is 30 meter map, the 30 meter satellite image. Let's say it's an image, not a map, okay? That's a special resolution. And what is a temporal resolution means? The satellites, they are orbiting the Earth, and it will come back again to the same point sometime in the future. Okay? For example, the Landsat we're talking about, the Landsat, it comes back to the same place in 14 days. So that is the resolution in time, or temporal resolution. This means time, and this means in space. So temporal resolution means how often the satellite comes to the same point. For example, if the temporal resolution of Landsat is 14 days, that means it comes to the same point every 14 days. So we can have same the image of the same place every 14 days. Okay, that's the temporal resolution. Now, why I'm telling you that is this is very, very important when we are working with satellite images, because according to our need, we're going to have to use the data. For example, if I'm working in like a whole area of Nepal, I can use the resolution which are small. For example, I can even use a resolution of 100 meter. Okay, 1 pixel is 100 meter. It doesn't make sense. It doesn't make difference if I'm using for the whole Nepal. But let's say I'm using for only this part. Okay, the part which is the airport. Let's say only this part. Now I cannot use the 100 meter resolution for this one because I need a really, really accurate data. So maybe I have to use a 2 meter resolution data. Okay, so this is what you have to understand. It's called the resolution. Okay, so and this is the terrain model of Kathmandu. It's the same place. So here you can see the Bagmati. This is northern side, and this is somewhere the Sitapaila area here, Gongabu over here. And then this is Bagmati going through like this in the down south. Okay, the airport is somewhere here, and it's not shown here. So this is the elevation map. You can see the up and down because the Kathmandu is not very flat, right? There are ups and downs. So you can clearly see the ups and downs here. These are also the satellite images, so you can get very, very clear image like this. Okay, so this would be very, very useful for what I'm going to show you later. Okay, so these are freely available. You can download these images. Okay, so I'm gonna go to landslide monitoring. Do you have any questions until here, or should I continue? Okay, I think I'll continue.
Amit, I think you have got a question. Do you have a question, Amit? You can ask if you have got.
Amit, please, you can ask. No problem. Yes.
Yeah. I think after landslide monitoring, I can ask a question. My question is related to this topic.
Okay. So do you want to ask now or after I finish the landslide?
After this landslide monitoring part.
All right. Okay. Thank you. All right. Let's see. Landslide monitoring. Let's talk about the landslide monitoring here. So what are the main causes of landslide? As I talked before, the main causes of landslide is a fragile and unstable geology. I'm sorry, the figures. And active tectonics, of course, and a large amount of precipitation in a short period. Precipitation can be rainfall, snowfall. What we have in Nepal is the monsoon climate, where we get almost 80% of our yearly rainfall, the annual rainfall, in less than 90 days. That's a huge amount of precipitation. If you compare that with the tropical climate, for example, let's say Singapore, or even southern India, they have rainfall all the year round. They have a lot of rainfall, of course, but all the year round. But in Nepal, we have almost 8 months dry, and then 3 to 4 months we have a huge amount of rain. So short period, a large amount of precipitation. That's also the main cause of landslide. And haphazardous development practice. Now I put the development in inverted comma because you might know there's a word, if you read the newspapers, if you see the social media, we can see the dozer because, right, the development. It's very, very haphazard. When people have dozers, they would just construct road everywhere, and these are real problems in case of landslides. That's one of the biggest problems nowadays in this last 10 years. Haphazard road construction, haphazard development practice is one of the main reasons of landslides in Nepal in the last 10 years. Okay. So landslides, they cause loss of life and property in the hilly regions, mostly in the hilly regions. And every year, people lose their life, people lose their property. Okay. And then access to most landslides are really difficult. It's a problem. Okay. You cannot go to the places where there are landslides easily. So manual monitoring of each and every landslide is very tedious and nearly impossible. There are many landslides in Nepal, and you cannot manually monitor each and every landslide. You cannot put cameras on every landslide and see if the landslide will occur somewhere in the future, or you can't do that manually. Okay, it's very tedious, and we don't even know how many landslides are there or how many potential landslides would be there. So it's nearly impossible. So what we do is that we use the remote sensing data with automation, of course. You write the codes, and then your computer will do the work for you, and it makes this easy. So I'll talk about how we do that, okay? So first, I will show you some examples of the landslide happened this year. This was this year, okay? Fragile geology, and I'll tell you, the soil, the rocks. If you bring that rock to your lab and test it, it's really strong rock, but it's fragile. It's detached, okay? And then this one, you can see the road here. That's what I was talking about, okay? The road. People constructed a road like this. And then this whole area collapsed due to that road. Because what people do is that they construct a road in stable areas, and then they make it unstable. And during a rainy season, the whole areas get collapsed, and then there's a village down here. Some houses were swept away. Okay, so this happens. This is one of the main cause of landslides in Nepal nowadays. So this was the Jure landslide. Jure landslide a few years early, 2012, I think. I'm not sure about that. Maybe 2012. So that was in Sunkosi River. Okay. And it was a huge landslide, and it dammed the river, and people were afraid that it will cause a flood because it dammed the river, it stopped the river, and the river started rising up. And then when the force of the river would be more than that wall created by the landslide, it will breach the wall, the water will fall down, and then we will have flood. That's a problem. It's a combined problem of landslide and flood. Okay. The river damming problem. So this was Jure, and this was taken from helicopter. I think this is the rotor of the helicopter. It's a very, very big one. Compare that with this. These are the people's houses, 2-story, 1-story houses, and compare the sheer size of that landslide. Okay. Okay, so then how do we monitor landslide? Okay, let's take a satellite image of Nepal, and then see here. This is the road. Okay, we can see the landslide here. This is the landslide because it's covering the road here. We have landslide here, we have landslide here, some landslides here. It means if we see the satellite image, we can clearly see the landslide. Okay, that's nice, right? We don't have to go there. If we have the landslide, if we have the satellite map, we can see the landslide. We can monitor that. Now, how do we monitor that? Okay, so this one I will show you. I think this was in 2010, 12, maybe 10. There was in the city, where the upper reaches of the city river. City means the city Gandaki in Gandaki region. This is the Annapurna range here. What happened was that the city river starts from Annapurna here, and then there was a rock avalanche. It's a landslide, of course, but from snow. And then compare that. This is a May 6th. This is April 20. Sorry, that was a little problem. This is April 20 satellite image, and then after few days, about like 16 days, there's another picture. Look at the difference. Something is here. Okay, forget this line. This line means these lines are created by the landslide. Sorry, the satellites, because when the satellites go above the Earth, and when they take the picture, sometimes they have this kind of lines. It's just as a figure, just in the photo. Okay, so here is snow, and after 16 days, see, there's a landslide. There's a rock fall here. And then all the dust and landslide debris went here, and the Setu River was dammed. The water started piling up, and then suddenly it breached, and then there was a flood down. Okay, so people couldn't go there. You cannot go. That's really, really, really remote area. Okay, you cannot go there. But then people immediately consulted the satellite image. Okay, this is 16 days later. So that's a temporal resolution. Just next photograph, and we saw, and then we can compare that. Okay, so if I go to this website, for example, let's say, if I go to this lens slide here, and here, this is the Earth Observatory lens slide, and then we can slide it here. This is the new old image. This is the new image. Completely check here. Here there was nothing, and here we have debris. And then here we can clearly see the grooves because the Setu River is very deep here. But then something is covering the Setu River here. Okay. So this kind of things we can do. We can have two different times, the photograph of two different times, and then we can compare. And that's one of the easiest ways to monitor the landslides. Okay. So this is the landslide detection. Let's see. This is the image of September 15, 2013. And then again in September 18, 2014, more than 1 year later, check. The landslide is very small. Here the landslide has grown big. Okay. And then what happens is that you can tell your computer to compare this area. For example, you can write a code in the computer, and it says like, compare the places which were green in the first picture and which has changed now. Okay, and then it marks these areas because this was green, this is not in marked area, and then you can go and check. Okay, landslide. And here the river has been dammed. Look, this is the Jure, the one I showed you earlier. Remember this one? The same one. Okay, check here. The river is very small. 1 year later, it falls down, and the river has grown. Okay. There's a lake forming here. So you can ask your computer, check that. You can write the code, and then if you compare the changes, then we can get this image. Okay. So it's a possible landslide, and this is probable landslide. Okay. All right. So this is also the landslide image after 2015 Gorkha earthquake. So people started using the satellite images, and then they started marking the landslides, because after every big earthquake, obviously due to our fragile geology, there will always be landslides, small, big. So this was a huge earthquake, 7.8. I think many of you felt that earthquake in 2015. Okay, so that created many earthquakes. One of my students, he did his thesis in this one, and he himself, like, he wrote the code, and then he checked, and he found around 20,000 small and large landslides. Okay, so then he trimmed them down to around 10,000, and 1,000 of them were really big landslides, like 100 meter, more than 100 meter big landslides here. Okay, so this is the Langtang village, this is Kathmandu, and this area was really suffered, like this area really suffered during the earthquake, right? So this square, this rectangle side, if I zoom it here, you can see a lot of landslides here. So what you can do is that this is a paper from a Chinese researcher, Jin et al. 2019. What they did was that they made some computer modeling. First, they took some satellite pictures, they marked the landslide, and then they asked the computer to check what is the difference between the whole area and the landslide. And they trained the model. Okay, and it's not like training a person, it's like training your computer programming. So they trained the computer model to find out the landslides, because there's a difference in color, right? And then they used that training module to find landslides. This is the area, the red dots are the landslides that were found by the program. That's a suspicious landslide areas. Okay. Now, where we can use this is that if we have a really remote area where we cannot go, or if we have some area that are probable landslides, because look at here, this was a landslide before, right? And then it just got bigger because there was the landslide in the past, and then it becomes a landslide. So if you can find these kind of landslides, we can find the probable cause of those landslides. Okay. So do you want to ask some questions, Amit?
Yes, sir.
Okay, please.
Yeah. So can we assume the possibilities of landslide to occur in a place?
Yes, we can. We can. So we call that, I'm sorry, I didn't put that one. Yeah, if I thought this question. It's called susceptibility map. Okay. So what the susceptibility map does is that it's just like our statistics. You have done the probability, right? Like the calculations of probability, very similar. What we do is that we take some factors that causes a landslide. For example, rainfall, or let's say haphazard road construction, geology, and then let's say south-facing and north-facing mountain, the hill. For example, if you take a look around you, you can see that many of our villages are on the southern face. Many of our villages are on the southern face. Don't go to the cities. Cities are different. If you go to villages, you can see most of our villages are on the southern side. Like this is a mountain or a hill. People don't stay on the northern side. People stay on the southern side, because southern side erode easily because there's the sun and the rainfalls are on the southern side. So these areas erode easily. So you can till the area, you can make agricultural land. That's why that area is also prone to landslides compared to the northern side. Okay, so northern side of any mountain, most of the mountains are forest area because people don't live there. No sun, because if you don't get sun, you don't make a village there. Okay, so from today, if you want to go somewhere, if you travel somewhere in Nepal, just think that most of the villages they have settlement on the southern face. Okay, so we put these kind of factors, and then we give them how to say, we give them a factor. For example, what do you think the main factor of a landslide is? Rainfall, or geology, or the slope angle? What do you think? So I say, okay, let's think rainfall is the most one, because we don't have landslides in the winter season. So then I put like 50% weightage in the rainfall. And then I calculate everything and I add it up, and then I get a point, like a probability. And then the areas which have the highest probability, which meet all the criteria for a future landslide, is susceptible to landslide. Yes, we can do that. It's called landslide susceptibility mapping. Okay.
And so
one of the reasons.
yeah.
Okay. So I'll show you here. Okay. So
And so
let me make it clear.
How can we get data sets for training the model, for automating the tasks of detecting the landslide? Yeah.
Okay. So here what we do is that first, for every landslide susceptibility mapping, you need what we call is a landslide inventory map. That means, just like you said, we need the data of the number of landslides we have. Okay. For example, the one I'm showing now, okay. Sorry, the one I'm showing now is the landslide inventory map. Okay. What we do is that this is a landslide. This all are landslide. How did we make that? We make that by this. Okay. We have two images, before and after, and we compare them, and then we train our model, and then tell the computer that, let's say, check the difference in color from your surrounding and here. If it's, let's say, if it is a shade of brown, maybe that's a landslide. and then you check every time. You check not only one, but you make thousands of iterations, and then the computer will be trained. Okay, your program will be trained. It can detect a landslide, and then you make a map just like this. So what we do is that the theory is, okay, let's say this is a landslide. Okay, all right, this is a landslide. Let me use the blue one here because it's red. Okay. So let's say this is one of my landslides. So what I'm going to do is that of this landslide, I will check the geology. I'll check the precipitation here. Let's say I'll check the slope, like what is the angle of slope, and then I will say how is there a road going from there, like this kind of factors. I take like 10 to 12 factors, and then what I assume is that here's a landslide already, and then if all these criteria are met by this place, for say, let's say this place, then there's a probability of landslide going on this place because this is very, very similar. Okay? Do you understand what I mean? Because we go to a place, like not physically, we go to a place where there's a landslide and check all the factors. Let's say this area is, geology is type of A type of rock, and the precipitation is, let's say, 100 millimeter, and let's say slope is about 40-degree slope, okay? And then let's say the road is about 220 meters from the haphazardly constructed road. So very similar area I found somewhere here. It also has the A type of rock. It also have more than 100 millimeter of rainfall. The area is also 40-degree slope, and the area is also nearly 20 meters from a road. But there's no landslide now. So what I say is that since all the factors are met, this area can have a potential landslide in the future. Okay, so that's how you can predict, not predict. I say you can mark the area susceptible to the landslide. Okay.
And so, how can I get the training data? Yeah, kind of.
Okay. So training data, you have to code. Now that's the problem.
Yeah. So I mean, that that how can I get satellite images to train my model to predict whether you can see in the screen share you are showing that. How can I get this data? Kind of these images, satellite images.
Yeah. Okay. For that, you can go to the Earth Explorer USGS, and you can download the images from here.
So I tried to download, but I didn't find it. Yeah.
Oh, really? Okay. So maybe I might have to show you how to do that in some class later. Okay. But what you do is that you go to Earth Explorer, you have to make an account, and then you choose the area you want to download, and then you can download that. But you need some spatial softwares to use that. For example, like ArcGIS, or you can use some GIS softwares for that. That's the problem. If you don't have that software, then I'm sorry, but you can't use that. If you have those softwares, then you can do that. I'll show you how to do that.
Dr. Subeg, I've got one question. So will I get an opportunity?
Yes, please.
So actually, while we just like monitor land degradation, hello, Amit, can you please mute yourself, Amit? Okay, Dr. Subeg, just like when we are monitoring land degradation and air pollution, I found a very nice software, or what can I say, something in the internet that's known as trends.org. I don't have so much of concept, but there was one platform, trends.org, where I can visualize the map regarding the land degradation and regarding the air pollution. But when I want to find out for this landslide, I could not find that sort of platform. So is there any other proper platform where we can go and then just see the data and then can come up with the visualization map? Something.
Yes.
Yes, please.
One
Yes.
very, very easy one is use Google Earth. If you use Google Earth has something called option is the history option. You can just slide and you can go satellite image. You can see the satellite images before the time. Okay, what happens is that most of these satellite images are not free. Sorry to say that because they are commercial satellites. They are not free. The one you can get from NASA, they are free, but there are commercial satellites which are very, very good images, but they are not free. So somebody has to buy that image. And if somebody buys that image, and now it becomes free, okay, because they already get the money from that group, okay. So Google Earth uses those free images. So if you want to go, please check Google Image as well. And I think there are some tools where you can download the Google image. There's a tool. I'm not sure. I don't have Google Earth here. No, I don't have in Mac. Okay, we can go to Google Earth, and then in Google Earth there's a tool called the history. I think you can just slide. There's a slider. You can slide and go back in time. You can please try that. I'm sorry, I don't have Google Earth in this computer, so I cannot show you that.
Okay, thank you. Thank you.
And
Thank
so,
you, Subeg.
Yes, yes.
Amit can go first.
yeah, I mean, can you get all this data regarding rainfall, precipitation, slope of the mountains through the remote sensing? Kind of.
Yes, okay. This image will give you the slope. And you can find there's something called DEM, that's a digital elevation model, very similar to this elevation map. So you can find the slope, you can find the altitude. But for rainfall, for Nepal, you have to contact the DHM, like the Department of Hydrology and Meteorology. And I'm not sure how good the data is nowadays. It might be really good, but you don't have a map. They will just give you the data and you have to plot it in your map for precipitation. And we can also use this satellite. I haven't checked it. There's a satellite, this global precipitation measurement satellite. You can go and check that. I haven't checked this because I'm sorry, that's not very directly related to my study. So I haven't checked this global precipitation measurement satellite. But if you go there in this page and then click here, then maybe they will have something for us. Okay, please, check that. And if you have any problem, you can ask me later through Rajendra. Okay.
So,
okay?
How can I contact you?
Oh, you can contact me through Rajendra sir, or you can just email me. I'll just give you my email. Okay. If you want to mail me, I will just write in the chat. Email me here. This is my work email, or you can just contact me through Rajendra sir.
Okay.
Okay.
Thank you,
right.
sir.
So please,
Sir,
no problem.
I have a
please. Yes, ma'am. Yes.
Sir, I have a question as well. Sir, why haven't we been able to develop any instrument that can detect the earthquakes like beforehand so that we save a lot of property?
Okay, so there's a lot of things going on about earthquake. A lot of money is being spent on the earthquake prediction, but earthquake, what happens is that I'm going to show you. I will go back here. We don't know where is this lock zone before an earthquake. We don't know. We don't know how much stress does it can it bear before it breaks. And then for one, we don't know when the stress is released, how big an earthquake will create. So this underground thing, because this is like 8 to 10 kilometer underground, so we don't exactly know many parameters. We have many unknown parameters, so we don't know exactly when the earthquake will happen. What we know is that Nepal is very prone to earthquakes, so we have to be ready. That's a little problem. Okay. I'll come back to that after I do the slide. No problem. Thank you. So I'll go back to that. I'll come back to that after the flood. Let me go to the quickly for flood. I'm sorry, I'm not very well versed in flood monitoring, but from what I have studied, I'll just show you. Like low-lying areas in Nepal, like the Tarai region or the river banks, are very susceptible to flood. So many people lose life and livelihood due to flood in Nepal. So what is the cause? Is the large precipitation in short period, obviously, and I just forget to put it. Our rivers are very steep. Okay, in Nepal the rivers are very steep because think about this. Nepal, the width of Nepal is less than 200 kilometers. Some place in the western, it's all of course it's wide, but in the eastern part of the central part, the width is less than 200 kilometers. And the height difference in the eastern part is from 60 meter to 8,848 meter. So more than 8 kilometer difference in 200 meter. So really steep. The rivers are really steep. That means the velocity is very high. There's a large precipitation in the short period. And then suddenly, when you go from the hillside to Tarai, and suddenly the rivers are like, let's say, this is a hill area. I'll write it here. Let's say, okay, so this is our hill. This is our hilly area. So, sorry, what's happening? Okay, let's say this is our hill area, and then suddenly we have the right here. The river is flowing in a very high velocity here. Suddenly, it has a lot of area to divert. Like it can go many areas because suddenly it gets the low-lying area, and then it will go really wide, and this is what makes the flood in the Tarai region. Okay, it was narrow, very high speed in the mountainside, and then suddenly it finds a way it can go around. It can go it can go wide, and that's where the floods will occur. Okay, and then one is anthropogenic. That means due to human. You construct your buildings, you construct a structure on the river bank, and when the river when the flood comes, obviously it will be under the water. Yeah, we can see that in Kathmandu as well recently. So this is also anthropogenic. That means due to human. And the space-based data, the satellite images, it can be used to monitor the rainfall, like the global satellites, and then we can use that to monitor the flood. Now, this one has been done many times in the past in Nepal as well. So you need to have a high resolution terrain data, just like the terrain data I showed you earlier, very high resolution terrain data. We know the height of every point here, like the height from the, let's say the sea level, we can know the height. And what it does is that then we can model in the computer, we can make a flood in the computer model, and then see like which areas will be under the water if a given rainfall. For example, let's say in computer model, what I say is that, let's say there is 100 millimeter of rainfall in 24 hours. Then I run the model, and the model will make the flood in my map, and then it will show the area which will be under the water. So that will help me create the vulnerability map, and I can tell the people like this area is very susceptible to flood. So if there's a big precipitation, because what happens is if it rains continuously for 24 hours, the river doesn't suddenly grow up, like get bigger. It takes time. Okay, so if we have that vulnerability map, and if you see a lot of rainfall coming, we can contact those people around those vulnerable areas and say that your area is really vulnerable to flood. Please go on the higher areas. So many of us now have, many of the families in Nepal, they have the access to mobile phones. Not all, but many of them, or many of people have the radio or television or the mobile phone that can be used. Okay, the government has to do that, of course, but I don't think it is in their priority now. So if we have the vulnerability map, and then if you see a lot of rainfall coming, and then the people on the red zone, we can just give them information, say like, okay, there's a danger of flood, get out. So you can save a lot of life. Forget about the property, we can save lives, and that's the most important thing, is saving people's life. Okay. An area susceptible to, sorry, this is a flood of my problem, sorry. I did a mistake here, this is flood. So areas susceptible to flood, it can be marked, yeah, and the people can be informed beforehand. So it will save people's life. For example, the people living on the bank of Koshi, we can tell them like, okay, the Koshi will be coming because there's a rainfall in the mountainsides, like in the hilly region, there's a lot of rainfall, and then the Saptakoshi will be getting bigger. Okay, the people in Saptari, please get on some place higher, and then we have to tell the people where to go. Like, okay, this place is higher, please go there, because the flood cannot come there. So that way we can save lives. Okay, so this has been done in many parts of the world, not from the government side in Nepal, but if you go to how to say, hydrology and meteorology department website, they have
I think
a online.
Easy mode as well, right, Dr. Subeg? Easy mode, are they doing the work on it?
Yes.
Easy mode.
Yes, Easy mode is doing a lot about this. Okay, and even the Department of Hydrology, they have the kind of real-time website where will show you, doesn't tell us that how far will that go, like which areas will be underwater. It just shows that the river is getting bigger. Okay, so not enough. Okay, so let's see. This is an example. This is in the Pakistan, Sindh River. This is a year earlier, in 2013, I think. This is 2000. Okay, this is 2012. This is in 2013. Let's see. These area, you can see compare the difference here. This area has been inundated with water. Okay, even this lake has become bigger. Okay, so if I go to this website here, and then here I can slide it. This is 2019 and 2020, of course. Look at here, the river is very small, and if I move here, the river has become bigger. This is in Pakistan. Okay, so heavy monsoon season has caused fatal flooding across Pakistan in 2020. 400 were injured, 400 people have died, and more than 200,000 homes were damaged or destroyed. Look at this area. This has become larger in next year. Okay, so this area, the people living in this area, obviously, they were underwater. So had we known, had we modeled this area as the red zone during flood, we could have saved a lot of life. Right? This can be used. Okay, we need terrain map, a very high resolution terrain map, so we can model that. We can say, like, let's say if we have this map, go back here. Let's say if we have this map, this is Bagmati here. Okay, draw the Bagmati River here. So maybe this like this, it goes somewhere like this. So we can say that if the Bagmati, if there's 100 meter of a millimeter of rain, Bagmati will rise 3 meters. So what we can do is that find the area 3 meters from the Bagmati, and we will mark them as red. Okay, so people living in this area will be in danger if there's 100 mm of rainfall. So there will be 100 mm of rainfall on one day, and we will call these people, or we can give them information like the SMS and say that danger, get out, and many people can be saved. Okay. So this has been done in other parts of the world. For example, in Bangkok, because Bangkok has really huge precipitation. They have a lot of rainfall in Bangkok, and then the Bangkok is on the bank of a river, the Bangkok River. So they have done this, and successfully they have done this in the past, and they are doing this now. And the place where I studied is in Hokkaido, is the northern part of Japan. What the problem was Hokkaido is that there was a river, and then when it was, of course, not many people there, and then the people from the southern side of Japan, they went there and made city. So what they did is that they turned the river. Okay, the river was something like this, So the Japanese, they wanted to settle here. They changed the river like this. Now every 10 years or so, the river will come here, because a river always wants to go to this old road. So these areas are like the flood susceptible, and then the people in this area will get notification if there's a huge rainfall. Like you might have flood. Please be careful. Or please go to.
And Dr. Subeg, I would like to. I was really fascinated by your data. Just like a river wants to go onto its own course every after 10 years, is it? Oh, okay,
not exactly 10 years, but mostly 10 years. So if you change the course of the river, because this is the artificial one, right? This is the artificial one. So the natural course of river. Now, River is a natural one, so it chooses its own path. Okay, the height difference, it chooses its own path. So if you turn the river artificially, and when there's a lot of water, the river wants to go on its natural course. So every 10 years or so, there's a big flood, and then the rivers come in this area. So of course, they have made walls and all that. We call that embankment, or in Nepali we call tatband. Right? Tat means how to say the bank, and band means to close. So tatband, and then the embankment. But sometimes it breaches that, it comes back. That happens in Kathmandu as well. Okay. So we say that this is this place used to be a river, and when there's a flood, the river comes there because it's this natural path. Okay. Okay. All right. So then this figure is June 2013, before the onset of monsoon in the northern part of India and the western part of Nepal. Just look at this river and compare that with before. This is before, this is after, sorry, it's opposite. This is before, you cannot see the water, it's in May. And then in June, the river becomes really big. This is Ganges. This is Ghagra River, that means the Mahakali River. It goes to meet the Ghagra here. Look at that, right? The river has really, really become bigger. This is 50 kilometer, this small line. So it's almost like 2 to 3 kilometer area. 2 to 3 kilometer area from the middle of the river was flooded. And you can see from the satellite, right? So satellite images are really, really good way of knowing what's happening, because you cannot go there and measure that. In satellite images, you can measure that. And then for the next year, you can say that, okay, last year we had, let's say, the flood in this area. So be careful. The people in this area, the river again might like come this time as well. Be careful. Okay, this area here. Look at that. Okay? There's a river. So you can say that. Okay, and then I think this is the precipitation map of that area. So total rainfall. There was a lot of rainfall in this area. That's why this happened. Okay, this area has a lot of rainfall. That's why the river swelled. The more darker, the more rainfall. Okay, so maybe in Uttarakhand area, there was a lot of rainfall. Okay. So this is I think this is a world precipitation map from that satellite. Yeah, I mean, you can please check the website if you are interested, and then please contact me if you have anything. Okay. So talking about flood, I will go to a new word: glacial lake outburst flood, or GLOF. Okay. So what are glaciers? Glaciers are river of ice. Okay, it doesn't flow, it slides because it's an ice. And then when it reaches down, the water melts and it turns into river. That's why our snow-fed rivers are there. So these are all glaciers, and the rivers and the glacier up to here, and then it turns into water and then flows down. So due to global warming, what happens is that the water is melting. For example, this was the glacier until here, and then slowly it started melting, and now the glacier has reached here. So this is a whole body of water. And now to talk about a glacier, let me tell you one. The glacier is a body of ice. It's sliding down, and it acts like a bulldozer. It takes everything with it, rock, sand, pebble, everything with it, and it forces it down. Okay. So this area, the end of the glacier, there is a huge wall of debris. That means the rock, soil, sand, everything is a huge wall. Okay, and behind that is the ice. Now what happens is that since the ice is retreating, that means the ice is melting and the glacier goes back, okay, leaving the water. So here is the wall created by the glacier. But the wall is just, how to say, it's not cemented, okay? It's not a wall we make like in our house. It's just the dumped material, not very strong. So gradually the water started getting bigger because there's a more of rain, more melting water, and then the force of the water will be greater. then this wall can bear, and then it breaks apart, and there's a flood downstream. The river will swell. There's a lot of water coming down. This is called glacial lake outburst flood, and this had happened in 1985. Many people died. We didn't know what happened. In the northern part, in the Tibetan area, a glacial lake was burst, and then in the northern part of Nepal, many people died. So you might have heard the word Chorolpa, right? That's a glacial lake. And then people were afraid that Chorolpa would burst, and then the Sunkosi River will swell. So people just put pipe here, and then water drop down, like this through the water. I think you know siphon. What is siphon, right? If I put water here, pipe here, and then suck it up, and the water will flow down. That's a siphon, because water will take its maintain its level. It goes down. So they use siphon to throw water. But this is not Chorolpa. This is called Imza. It's Imza Sho. Sho means lake in Tibetan. So it's the Imza glacier. It has retreated. It's a very, very high resolution image. This is a 1 kilometer area. So it's like 2 kilometer into 1 kilometer, big lake. So this is the Lhotse glacier. This is the Lhotse Imza glacier. It's retreating. And if this area breaks, there's a flood. That's why Imza Lake is being monitored every year. People have been monitoring that. Isimud has been doing that as a reasonable said. My friend, he's also working. He's an environmental science student. He's doing his PhD in Glacial Lake. So he's also monitoring Imza. One of his monitoring is Imza Lake. He's monitoring that as well, because they think that if the Imza is getting bigger, it might create problem in the eastern side, in Arun River. Which is Arun. So this is what, let's go to earthquake monitoring. As the ma'am first said, earthquakes, we cannot predict yet. No, that's a problem. Okay, so only way is to get ready with resilient structures. So we as who work with earthquake, we don't say earthquake-proof structures. Nothing is earthquake-proof. Okay, nothing is earthquake-proof. But we say resilient structure. That means my structure can withstand some of the earthquakes. That's the resilient structures. Because in earthquake science, what we say is that earthquake doesn't kill people. Like if you stand on the ground and there's an earthquake, you cannot die. You won't die. But if you're inside a house and the house will collapse, you will die. So our structure kills people, not the earthquake. Okay, and we cannot predict the earthquake. What we can do is that if there's an earthquake, let's say the earthquake happened in Gorkha, then the earthquake waves, it will take some time to reach Kathmandu. Okay, and the velocity of the earthquake waves is very, very, very less than our electromagnetic waves, which is the velocity of the light. So if there is a mechanism of giving information from Gorkha to Kathmandu through radio waves, what we can get information before the earthquake arrives here. Okay, so that's not prediction. That means, okay, let's say the earthquake is happening here, and the wave will travel like this slowly to Kathmandu. Let's say this is Kathmandu. Okay, so this is the speed is like, let's say 3 kilometers per second. 3 kilometers per second. Okay. But then we, if somehow we have an instrument which detects this earthquake, then it gives information to Kathmandu in 3 into 10 to the power 8 meter per second. So 10 to the 3 into 10 to the power 5 kilometer per second. Very fast, right? 10 to the power 5 times faster than that. So before the earthquake waves arrive, we'll get information like, oh, earthquake is coming. Okay? But it's not prediction. It's just you get information beforehand. So this has been being practiced in Japan, in Taiwan, in the United States. And the Nepal government tried to do this after 2015 Gorkha earthquake, but the problem is money, budget. It takes a lot of money to do that because we need this kind of small stations all over the country. We don't have that yet. Hopefully, maybe if the government is willing, we can have that in next 5 years or so. That way we can know the earthquake is coming, so you will get time to go to a safe place. Okay. So that's not prediction. So But prediction, we cannot say. Like, nobody can say that the earthquake will come after 2 days. We cannot say that. Okay. So now, so what can we do if we cannot predict the earthquake? Like landslide, we can predict the landslide. Okay, you can say that, okay, this place is very, very vulnerable to landslide. But we cannot say like your place is vulnerable to earthquake. I don't know. We cannot say that. But we can say that your structure is vulnerable. Make a new building. We can say that. But we cannot predict earthquakes. So what are we going to use?
I want to interrupt you here. So
Okay,
if that is the case, why the people are dying every year in Sindhupalchok? So if we can predict landslide, then why are they dying? Are we not making them alert or?
No, they are not. That's the problem, sir. That's the problem, Vijayendra, sir. The government, I'm not sure. Like we talked about this with a professor, my professor from Kathmandu University. They gave a report 2 years earlier in Sindhupalchok. There was a landslide a month earlier, I think, like 3 weeks or 1 month early. Many people died, right? So they gave a report to the government saying that that particular area is vulnerable to landslide. Please do something. Okay. Nobody did anything. I don't know. That's very bad. They said that they really said that this area is vulnerable to landslide. Okay, please do something, and nobody did anything. And also, there's a problem with people as well. For example, let's say I live in a village. Let's say ABC village. I have been living there for 50 years. Okay, there is an old landslide above my building, like my house, like this slope. This is the slope. So our villages, like if this is a slope, our village will be here. Now, in geology, this type of terrain is not possible. The terrain would be like this. Why is this like this? Means this area might be an old landslide, geologically. Maybe not, but mostly this might be an old landslide. And then I've been living here for 50 years. My family, my father lived here. Okay, I do farming here and everything. So this area is slowly moving down. I don't know. This is an old landslide. So when I do study by the geologists, they study and they say that, okay, this area is vulnerable. Please move these people somewhere down. Will I move? No. What do I say? I've been living here 50 years. My father used to live here. We didn't have any problem. We won't have any problem in the future. Okay, that's a problem. So maybe the government could like buy this land to give the people land somewhere else, give them work. Maybe they can move. But just say that, okay, this place is very, very dangerous. Go out. Nobody will move. Okay, that's the problem. That's not a technical problem. That's a kind of a bureaucratic or political problem. Rajendra sir, did I make it clear?
Of course, it is really, we are getting a lot of insights, really.
Yes.
And then all these are focused for space excellence. Actually, this talk is to be listened by every team members, those who are participating. Okay. Really, very insightful and very interesting.
Okay, so thank you. So let's go forward. So let's say you might ask, like, if you cannot predict earthquake yet, what are we going to use the satellite images or the space-based images for? Okay, for that, the space-based, sometimes the ground-based data can be used to monitor, analyze the damage after the earthquake, and then monitor the secondary effect, for example, landslides. Like I told you, after 2015 Gorkha earthquake, there were many landslides. Okay. Some of the videos you can even find in internet. Okay. So we can monitor those effects, and we can monitor and analyze the damage. I'll give you an example. After 2015 Gorkha earthquake, I was not in Nepal because I didn't feel that earthquake. I was in Japan studying. I was the final year of my master's. I haven't even started my PhD at the time. So space data were used to understand how much the crust beneath Nepal moved, because of course it's an earthquake, it moves. So space data were used to understand how much the crust moved. And then there's a word called crowdsourcing. People were asking volunteers, like if you have time, see the images, like before and after the earthquake, and please mark the area of damage. Like Amit asked me questions about how do we train the for the landslide. Similarly, they were asking people to do it manually, okay? Because after an earthquake, many people were panicked, and then the people outside Nepal, they had time. They were just looking up. I was spending all my time in the computer because I want to have news from my home. I want to see what's happening, and then I also work here, like for this, like I volunteer for crowdsourcing. What does it do is that, for let's say, it was done by a website called Tomnod. Okay, you can find this in the internet. What they did was that, for example, they had a satellite image of before. Look, this is a really, really good resolution. You can even see people here. Right, really good resolution. So this is before the earthquake, and this is after the earthquake. Now they will give you two images, like very big image. You can slide that, like the slider I showed you earlier. You can slide that, and then they ask the volunteer to mark the area damaged. So they will give you three options: green, orange, yellow, orange, and red, something like that. Red means completely damaged. For example, this Tarara, I will mark red, completely damaged. And then, for example, let's go to, there's another collapsed building somewhere here. This one. So, this one will collapse here. So maybe this is collapsed, partially collapsed. I'll give this yellow. And then some not collapsed, I'll just let it be green. Okay. Because if you want to do it for a huge area like Kathmandu, Kathmandu is not small, really, it's big. If you want to do it for a huge area like Kathmandu, it will take a lot of time. Okay, so they were asking volunteers all over the world to do that, and then they made this kind of map. Very good. Okay, so they will have green, a little damaged. So this is a little damaged, non-damaged, and red is damaged. This is Kathmandu, and somewhere this is the what's that area? Bhaktapur area, and some of this is Bhaktapur. This is Sakhu. There's a more damaged area on the western part. And sorry, this is not from my view. This is somewhere in the Gongabu area. It was damaged. In the Sitapaila area, it was damaged. Remember that? Okay. This is the airport area. Not many damaged things here, like this. So this was made by people. It's called crowdsourcing. Okay, crowd. They ask people to go to that satellite image, zoom it in, look, check which get damaged, and then click it. So what did it do is that it became very, very easy for the planners of the government people to go to this place, because, oh, so this area is red, that means many buildings will collapse here. So maybe we have to take the help there, like the food items and other things. We have to take those rations at this place, so you can know exactly. Otherwise, you cannot send people to every part of the Kathmandu city and then ask like how many buildings get damaged and all that. It takes a lot of time. Okay, so this is a Tomnod. So this is the satellite image. They made a map like this. Okay, so this is somewhere in Birgunj. This is Kathmandu. This is Langtang here, and the check that. Okay, so they made a map. Very good map. So most of the damage was in Kathmandu and north of Kathmandu in Langtang area, and very much less in the Tarai region and not in even Pokhara. This is Gorkha a little. Sorry, this is Gorkha. It's in the western part. Butol is here in Palpa area. It's much less, kind of. Okay. So this is what they made. Very, very fast. They did that in 2 to 3 days. Why? Because they used many people. They used the satellite data. I didn't have to be here. I made some of these. I don't know, some of these. Maybe I made it Bhaktapur because that's where my city is. So I was more concerned about that. But anyway, so this is the kind of thing people have been doing nowadays. Very helpful, right? So this is a GIS, and they showed the GIF image. It's like how fast this can be done. Okay. So every yellow means people working here. It's very fast. This is Kathmandu area, and they just mapped it in Nepal. Many people mapped it. Okay, green, 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 red, 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 red. This is what happened. Okay, very fast. Okay, so I'm going to go back to the landslide, because many landslides, I told you, many landslides were occurred during this earthquake. So this is April 27, 2014, 1 year earlier than the Gorkha earthquake. This is the Langtang village, Gubacham Mundu. This is a trekking route, okay, Langtang. And then look at here, a big landslide, a big one, because look, this is a 2 kilometer, so it's more than 1 kilometer wide. Think about the sheer size, 1 kilometer wide landslide collapsed this whole area. This Gumba and Langtang village was under the landslide. Okay, this happened. This is the satellite image after 5 days. And don't panic about the color. We call it false image, because this is an infrared image. So that it becomes very, very helpful to clear the cloud. Because if I take the picture from the satellite, it will some places will have cloud cover, right? There will be cloud, so I cannot see through it. So if I use the infrared, I'll just get the heat map. Types of images. So this is a IR. We call that infrared image. So this is the Langtang village, and this whole village could collapse. That's right. Look at this. I'll go back again. This is one before, April 11, 2014. This is the satellite image, and this is the image later. Here, look at that. Compare that. Here, look at the road. Sorry, this is the river, okay? But the road is also parallel here. People will go like this, and then here's a landslide. The river get dammed. A big landslide. Look, more than 1 kilometer. Okay. This is a figure from lindsaynicholson.org. This was a Langtang village before and after the earthquake. Nothing. Same place. Nothing. Because a huge landslide came from this area and then it collapsed. All the buildings, the few buildings remaining here, most of all the buildings were beneath the rubble. Okay, so that's the problem. People might not know about it if we didn't have satellite images. You know what I mean? If we didn't have satellite images, people would not have known about it for many, many days. But we knew it because people were looking at satellite images and said, wow, what happened here? And it's very dangerous. So then we can see there, and we can estimate the size of the landslide. And you can see that, wow, there's a big landslide in Langtang. And then rescue can reach there. People were waiting, okay? They might not have phone. They couldn't contact Kathmandu, but we have satellite images. We can find that. It's a rescue operation is very, very fast like this. Okay, so I will talk to you about, I'm going to finish, I have 3 almost slides here. So there's a interferometric synthetic aperture radar. The name is really difficult. We call it INSAR. That's a radar. If you have no radar, that's radio and imaging, decoding and imaging. So what does it have? It's a satellite image, Sentinel satellite by European Union, and it has a kind of how to say, two cameras and 2 radar cameras. What it does is that it takes a photo now and takes a photo later. Okay, so and it measures the difference. Like the light will go down to the ground and come back, and then another ray will go and come back, and it will check the difference between those rays. Okay, and I don't want to go into very detail about this, but what it shows is that it can measure changes in the deformation. Like if there's a little deformation in the ground, for example, even in millimeter, this INSAR image can show you. So it's a satellite image just like this, and it can show you the change in the elevation. So what people used it, what the researchers used this for, means there's a main shock here. There's a Gorkha main shock on April 25 or 12 Baisakh, and this was on 29th of Baisakh. That's 15th of May. 12th of May on that day. So this area, can you see the how to say, the disturbance here. So what does it say is that the ground or the crust of Earth, this whole area got disturbed. Okay, we could find from the satellite image, this area got disturbed. So that means this whole area should have been affected by an earthquake. It moved. This area moved because remember I told you when I was talking about the tectonics, the Indian plate is pushing down, and then the rock is like stopping it, and this energy gets stored here, and suddenly it moves. And a few area it moves, and this whole area moved. This area. There's a change in crust, so you can find that. So what they did is that this is the close to satellite and away from satellite. That means up and down. So it moved up and down. Right? Somewhere it moved up, somewhere up down. But there was a difference in satellite. In the crust altitude. In millimeter, of course. In centimeter, 12 centimeter, not much. Okay. So, and there are many things I don't want to tell about because I don't want you to get confused. But let's say the southern part, this is India, Nepal, our mountains, Annapurna, and this is not Takkula, it's Takkula. If you have known Takkula, the people, Thakali people live here. It's in Mustan. If you have been to Mustan, you go through this Takkula. So what they say is that somewhere 5 to 10 kilometers down, this whole area, it moved. There was a stress here, this area was locked, and then suddenly there was an earthquake here because this area moved. Okay, so this is the map they made by this image. That means you cannot go dig deeper and see how deep the earthquake was created, but from these images we can now know. Okay, this is an indirect method. So this is the whole Kathmandu. If you can see here, I'll just remove the ground displacement meters towards Sentinel. Sentinel means the name of the satellite. So this is the uplift. The northern part of Kathmandu, it moved nearly 2 meters up. So if this area was 1420 meters above sea level after an earthquake, it became 1422 meters. Moved whole area on the northern side of Kathmandu. And then some places, again, north of Kathmandu, south of Langtang, it moved down somewhere like 2 meters. So this was like moved up and down. So you can clearly see from this image as well, right? Moved up and down
Subeg,
somewhere here.
Subeg,
Yes, please.
Subeg, the previous slide that you showed, the image, that satellite image, that was of Sentinel, right? So is it of European Space Agency? Is it of ESA?
Yes, Sentinel. Yes,
so I think
no,
this is from
European Space Agency.
Yeah, so I think we can get this sort of images from if we go to ESA, right, website. So I was thinking about this particular. Okay.
Okay, Sentinel is freely available, I think. So, but I haven't used this image because I'm not very sure about this. But it's free. But I'm not sure about what is the format of this image.
Okay.
I can check that. I can check
okay,
that. I'll check that. But this Sentinel means this is from the European Space Agency, not NASA. Yeah, ESA, European Space Agency.
So Amit might use this one. So if he is here,
yes,
is he?
Amit can.
Yeah.
Yes, he can do that.
Yeah, you can
and
use
this can
this
also
one,
be
Amit,
used for the. Sorry to interrupt, but this can also be used for landslide, I think. Because if I focus on some area and if it has moved, then maybe you can use it. I think it can be used. You can just make a kind of an idea. I think it can be used. Okay, so about the ground base, I will give you an example. What happened is that after the Gorkha earthquakes, we used the students. I was not in Nepal, but I was also working in the Khowpa Engineering College before I went to Japan. So a few of our students, they went door to door in Bhaktapur. Okay, so they wanted to collect the damage information. So what they did is that few of the computer science students, they made an Android app. Okay, and a very crude app they made. And what they had is that they could input the house owner's information, the name, age, and the place where he or she is. And then the damage situation, for example, what kind of damage? Like in engineering, okay, the pillars, the column, which we call pillar in general term, the pillar was damaged, or the beam was damaged, or the whole wall collapsed. What kind of damage situation they could input there? And then the house of building type, like the old kind of the masonry building, or the concrete RCC, or the cemented building, or the timber building, like the wooden houses, the house building type, and the location. They had the GPS, of course. They had the GPS. It's a mobile phone. They had GPS. They had that information as well, and they took photos. Okay, so this whole thing, after the app, they just came to colors and they connected the mobile to the computer, and they could download and then make a database. So what they had was that they had the information of owner, they had the damage situation, kind of building, the location, and even the photos. So this was later used by the municipality, Bhaktapur municipality, to make plans for the help and rebuilding. Like this area was really damaged, so we can help that. Okay, this monument was damaged, let's do that. So this is a typical example of how you can use that. Okay, this is a ground-based one, not a satellite image. They didn't use anything. They used the ground-based data as well. But Bhaktapur is a small place compared with Kathmandu. Of course, it's a small place. You can do that. But as a use place, for example, let's say central Nepal, you cannot do this. So you have to use the cloud, the space-based data. Okay, just wanted to compare one or two things. Okay, so finally, space data, it can be used and has been used for natural and hazard disaster monitoring in the past, even in Nepal. We are lagging in some part, of course, but people have been using this. So our country, with small economy and very few technicians, we have really few technicians working in this disaster management area. They can hugely benefit with these remote sensing techniques. So what I'm going to tell students is that please brainstorm, think about it, and think how or what you can do with the space-based data. You don't have to be really expert in that. Just think, can I use this? Can I use this for this? It can be a really good idea. Maybe there are some people out in the world who can use your idea to, how to say, in real world. For example, you make an idea, and then maybe some people from other countries, they can contact you and they can really make an app or really make some ideas about that. So please brainstorm, talk with some people, talk with us, and then see what you can do and what you can do and how you can do the space-based data for disaster monitoring. Thank you.
Subeg, I would like to ask one question. Hello?
Please. Yes.
It's like यो काठमाडौँ चाहिँ एपिसेन्टर हो कि हैन अर्थक्वेकको?
होइन सर.
हैन है? भने पछाडी त त्यो सिग्नल हामीले युज गर्यौं भने त्यो जुन चाहिँ थियो नि अहिलेको डिभाइस त्यो इलेक्ट्रोम्याग्नेटिक सिग्नल अथवा चाहिँ हामीले चाहिँ त्यही तरिकाले जुन चाहिँ जापानतिर भइरहेको छ त्यस खालको स्ट्र्याटेजी अपनायो भने त नेपालको मान्छे त बाँच्ने रहेछ नि त हैन? हैन काठमाडौँको मान्छे अथवा यो भ्याली भित्रको काठमाडौँ भक्तपुर ललितपुरको धेरै नै क्याजुअलिटी त कम हुने रहेछ नि हैन?
मैले बुझेँ. यस्तो म एकचोटि सानो यसमा देखाउन चाहन्छु. लेट्स से दिस इज our Nepal. Okay, so this is somewhat like 900 kilometer, right? 900 kilometer, and this is somewhere like 200 kilometer. के हुन्छ भने
थोरै ठाउँ भयो है हाम्रो,
एकदम थोरै छ. दिस इज काठमाडौँ.
एकदमै थोरै ठाउँ भयो.
काठमाडौँ यो भयो. अनि अर्थक्वेक कहाँ जान्छ हामीलाई थाहा छैन. द्याट्स द प्रब्लम. अनि हामी अहिले के भन्दैछौँ भने मैले नेपालीमा भने लगभग यो वेस्टर्न साइडमा पोखरा भन्दा वेस्टतिर चाहिँ ठुलो अर्थक्वेक जाने सम्भावना छ भनेर भन्छ. किनभने त्यहाँ अर्थक्वेक नगएको धेरै भयो है. सो त्यहाँ अर्थक्वेक जाने सम्भावना धेरै छ भनेर भन्छौँ हामी. अनि यदि यहाँ अर्थक्वेक गयो भने यो वेभ त यहाँसम्म आउनलाई धेरै समय लाग्छ. लेट्स से 400 किलोमिटर छ भने झन्डै 100 सेकेन्ड लाग्ने भयो हैन? 100 सेकेन्ड लाग्छ. त्यो भनेको झन्डै 1 मिनट भन्दा धेरै. अनि यहाँबाट यदि हामीले यस्तो सानो इन्स्ट्रुमेन्टहरू धेरैवटा सेट गर्न सक्यौँ भने यो इन्स्ट्रुमेन्टले पहिला अर्थक्वेक फिल गरिहाल्छ अनि उसले यहाँबाट यहाँ काठमाडौँमा सूचना दिन्छ. अब यो चाहिँ हाम्रो स्पिड अफ लाइटमा जाने भयो हैन, सीमा. त्यसले गर्दाखेरि हामी केही सेकेन्डमै पाउन सक्छौँ. लेट्स से 1 सेकेन्डमै पाउँछौँ भने अनि अर्को 2 सेकेन्ड भित्र हामीले सबै मान्छेहरूको मोबाइलमा पठाउन सक्छौँ. त्यसो गर्दाखेरि यो मान्छेहरूले चाहिँ ल भैँचालो आउँदैछ भनेर भन्छ. 30 सेकेन्ड जति पछि अचार आइपुग्छ. बट यहाँको मान्छेहरूले चाहिँ पाउँदैन उनीहरूले इन्फर्मेसन पाउन्जेलसम्म उसले अर्थक्वेक फिल गरिसक्छ
कहाँको मान्छेले चाहिँ
जस्तै अब यो बजाङ भयो भने मुगुका मान्छेले चाहिँ त्यो नपाउने किनभने उसका अर्थक्वेक आइसकेको हुन्छ अब काठमाडौँको नर्दर्न साइडमा पनि अर्थक्वेक जाने चान्सेस धेरै छ रिजन सर
सर अगाडि चाहिँ थाहा पाउन सकिदैन
थाहा पाउन सकिँदैन द्याट्स अ प्रब्लम अगाडि थाहा पाउनको लागि पिपल हेभ बिन वर्किङ अ लट मेबी तपाईँहरूले आजभोलि एउटा त्यो फेसबुकहरूमा पनि देख्नुभयो होला एकदम धेरै गडेउला निक्लियो अर्थक्वेक आउन सक्छ यताउता भनेको देयर आर सम पिपल हु वर्क द्याट त्यस्तोमा पनि एनुअल बिहेभियरमा पनि स्टडी गर्ने मान्छेहरू छ तर उनीहरूले एक्ज्याक्टली यही कारणले गर्दा अर्थक्वेक गएको भनेर भन्न सक्दैन अर्थक्वेकै कारणले गर्दा अर्थवर्म निक्लेको भन्नु नि भन्न सक्दैन सो इट्स अनि एउटा के भन्छ भने हामी कहाँ त्यो कुराहरू चाहिँ एनिमल बिहेभियरको कुराहरू पनि अब मान्छेले कथाको रूपमा जस्तै भन्छ कि भैँचालो गइस होइन सो त्यो चाहिँ कस्तो भयो भने अर्थक्वेक पछिको मान्छेको कथा भयो क्या अब कति पत्याउने कति नपत्याउने हो कि होइन भन्ने कुराको लागि चाहिँ इट्स रियली अब मैले भने रे त्यो दिन त यस्तो भएको थियो भने प्रवेशले सोचेर त्यो दिन त धुम्म बादल पनि लागेको थियो भन्नु भन्छ त्यसको अर्थ एभ्री बादल लागेको दिनमा अर्थक्वेक आउने भन्ने पनि होइन अनि फेरि कसैले भन्ला लकीले भन्ला एकदम कुकुर भुकेको थियो मेरो घरतिर फर्केर बिहान 11:30 बजे अनि 11:15 त पैसाले गइहाल्यो भनेपछि एभ्री डे कुकुर मेरोमा भुक्ने बित्तिकै अर्थक्वेक गयो भनेर भन्नु त मिल्दैन सो त्यसलाई एनेक्डोटल भन्छ अनि पोस्ट हक भन्छ अर्थक्वेक गइसकेपछि मान्छेको कथै भन्छ त्यो एनेक्डोट भनेको त कथै हो होइन मान्छेले भनेको कुराको आधारमा हामी अर्थक्वेक प्रेडिक्ट गर्न सक्दैनौँ दिस इज नट साइन्स एक्चुअली
यस सर सर अनि त्यसपछि मैले रेडियोमा पनि सुनेको थिएँ अब चाँडै नै अर्को अर्थक्वेक पनि आउन आँटेको छ अरे भनेर
आउन आँटेको छ भन्दाखेरि चाहिँ कस्तो छ भने ओके अगेन गो ब्याक है म फेरि
ओके सर अब
मेरो स्लाइडमा एकछिन जान चाहन्छु तपाईँले एकदम इन्ट्रेस्टिङ कुरा गर्नुभयो म ब्याक
यस सर
भने छैन हैन ओके आइल गो ब्याक अर्थक्वेकमा के हुन्छ भने लेट मी गो ब्याक टु भेरी फर्स्ट बिगिनिङ हियर ओके यहाँबाट यो ठाउँमा लक्ड भनेर एनर्जी स्टोर भइरहन्छ सो द्याट एनर्जी सुड रिलिज टाइम टु टाइम रिलिज भएन भने धेरै एनर्जी स्टोर हुने भयो अनि एक्कासी अर्थक्वेक जान्छ है जस्तै मैले यो कलमलाई यसरी बङ्गाएँ भने एउटा स्टेजमा पुगेपछि यो कलम भाँचिन्छ हेर्नु अलिकति बाङ्गिन्छ तर एउटा स्टेजमा चाहिँ भाँचिन्छ जति धेरै बङ्गाएँ एउटा स्टेजमा पुगेपछि भाँचिन्छ अलिअलि मात्र बङ्गाएर छोडे भने भाँचिँदैन करेक्ट यहाँनिर नेपालमा के भयो यो एरियामा हेर्नुहोस् न अर्थक्वेक गएकै छैन what does it say means यो एरियामा जुन स्टोर भइरहेको छ एनर्जी त यहाँदेखि यहाँसम्म कम्प्लिटली स्टोर भइरहेको छ एनर्जी सरी हैन मैले अहिलेको इमेजमा देखाएँ भने यहाँनिर हेर्नुहोस् भइरहेछ है
यस सर
तर यो ठाउँमा एनर्जी रिलिज भएको देखिएन यो ठाउँमा अलिअलि रिलिज भइरहेछ यो ठाउँमा रिलिज भएको देखिएन त्यही भएर रिसर्चरहरूले अहिले के भनेको छ उनीहरूले यहाँ के गरेछ भने एक दुईवटा यो ठाउँमा यसरी ठाउँमा उनीहरूले जिपिएस हालेको छ जुन अघि मैले भनेको ह्यान्डल जस्तो होइन एकदम ठुलो जिपिएस हालेको छ जसले मिलिमिटर एक्युरेसीमा नापिन्छ मिलिमिटर अनि उनीहरूले के गर्यो भने यो एरियाहरू यता मुभ भइरहेछ अरे सबै यो एरिया मुभ भएको छैन बा भन्छ मुभ नहुनुको अर्थ के हो भने एनर्जी स्टोर भइरहेछ करेक्ट पहिला अघि भनेको थिएँ मुभ भइरहेछ भने त एनर्जी स्टोर भएको होइन इफ इट्स नट मुभिङ डाउन नट मुभिङ नर्थ साइड द एनर्जी इज बिङ स्टोर्ड अनि एनर्जी स्टोर हुँदै गर्दाखेरि एनर्जी रिलिज त हुनु पर्यो हो भनेपछि यो ठाउँमा चाहिँ धेरै एनर्जी एकैचोटि रिलिज हुने चान्सेस भएको कारणले गर्दाखेरि अब पोखरा यता समवेयर हियर छ होइन गोर्खा भयो पोखरा यहाँ भयो समवेयर हियर जाजरकोट मुगु एरियातिर यहाँनिर चाहिँ ठुलो अर्थक्वेक जान सक्छ भन्नु भन्छ एउटा त्यो अनि दोस्रो हामी अर्थक्वेकमा के भन्छौँ भने वेयर देयर आर अर्थक्वेक्स भन्छौँ सुन्दाखेरि अचम्म लाग्छ सानो अर्थक्वेक गइरहेको भनेको ठुलो अर्थक्वेकको इन्डिकेसन पनि हो इट वर्क्स अन बोथ साइड अलिकति उल्टो पनि छ अर्थक्वेक जाँदै गएन भने पनि समस्या सानो अर्थक्वेक गइरहेको भने पनि समस्या त्यसको अर्थ के हो भने साना अर्थक्वेक गइरहेको भनेको चाहिँ यो पेन्सिललाई मैले बिस्तारै बङ्गाएँ इफ यु पुट योर इयर नियर तपाईँले अलिकति क्रक आवाज सुन्नुहुन्छ भाँचिनुभन्दा अगाडि त्यो भनेको बिस्तारै एनर्जी रिलिज हुन थालेको सानो अर्थक्वेक गएको भनेको त्यो पनि हुनसक्छ एउटा अर्को बङ्गाउँदाखेरि आवाजै सुनिएन यो त्यो चाहिँ यो स्टेज हुन सक्छ the first stage second stage third fourth कुनमा छ we don't know right that's why the पत्रिकाहरूले भनेको चाहिँ त्यो there can be a large earthquake in western Nepal really there can be an earthquake we don't know है म तपाईहरुलाई त्यसो भए एउटा सानो एउटा देखाउँछु if you have time let me show you one thing okay so I'll show you another slide यो मैले हाम्रो मास्टर्स को स्टुडेन्टहरुलाई पढाउने एउटा स्लाइड हो म तपाईहरुलाई स्लाइड देखाउँछु म उनीलाई उहाँहरुलाई के भन्छु भने स्लाइड मैले पढाउँदाखेरि चाहिँ यसरी भन्ने गरिरहेछु okay so this is the one the paper you mentioned we're talking about Wilhelm भन्ने मान्छे रोजर विल्हम he's a real good scientist he is working a lot in Kathmandu उले पहिला के गर्यो भने sorry not Kathmandu नेपाल उले पहिला के गर्यो भने उले 2005 मा एउटा काली व्यालेस भन्ने मान्छेसँग काली भनेको उसको नाम हो इट्स नट इन्डियन or नेपाली काली व्यालेससँग रोजर विल्हम र काली व्यालेसले 2005 मा उनीले यसरी नै यो ठाउँमा स्टेशन्सहरु राख्यो जीपीएसहरु अनि उनीले नापेर उले के भन्यो भने यो 8.6 भनेको 8.6 म्याग्निट्युड सम्मको अर्थक्वेक जान सक्छ काठमाडौँ यहाँ छ यता 7.4 को जान सक्छ 8.1 को जान सक्छ भन्ने एउटा म्याथ निकालेको 2005 मा आफ्टर 10 इयर्स यो ठाउँमा हेर्नु त यो मैले रातोले मैले चिन्न लागेको हो यो 7.8 को अर्थक्वेक गयो ओके सो दे सेड our prediction is more or less true हो प्रेडिक्सन त होइन तर उसको एस्टिमेसन ट्रू भन्ने कुरा भयो उले के भन्यो त यो एरियामा 1505 पछि भैँचालो गएकै छैन इट्स बीन मोर देन 500 इयर्स सबभन्दा ठुलो अर्थक्वेक यो एरियामा 1803 मा गएको अलरेडी 2.5 इयर्स sorry 250 years more than that हैन यो ठाउँमा 1905 मा गएको सो दिस एरिया हैज नट सीन लार्ज अर्थक्वेक यो चाहिँ 1934 भनेको हाम्रो 90 सालको भैँचालो यो ठाउँमा अर्थक्वेक धेरै ठुलो जान सक्छ भन्ने भनेको 7.8 को त्यतिबेलै गयो सो दे डिड द स्टडी अगेन अनि उनले के भन्यो अब भर्खर गएको गएर यहाँ चाहिँ अर्थक्वेक अहिले जगत्तै आउँदैन तब पोखरा भयो अब स्पेलिङ अर्कै लेखाछ पोखरा भन्दा वेस्टर्न साइडमा अहिले पनि भैँचालो गएको छैन भने यो एरियामा स्टिल 8.7 सम्मको अर्थक्वेक जान सक्छ नाउ द वर्ड सम्म अप टु 8.7 that means it can be 5 6 7 8 or 8.7 we don't know but if there's a larger earthquake in this area it has a potential to create an earthquake up to 8.7 magnitude okay to understand that
yes sir
right
kind of
that's a problem त्यही भएर हामी के भन्छौं भने हामी अर्थक्वेक साइन्स पढ्नेहरु अथवा अब काम गर्नेहरु भनेको always be ready मेरो त स्ट्रङ मोसन भयो बिल्डिङहरुको बारे हेर्छौं हामी सो बिल्डिङहरुलाई चाहिँ हामी के भन्छौं भने डोन्ट कम्प्रोमाइज गभर्नमेन्टले कोड बनाइदिएको छ डोन्ट कम्प्रोमाइज हाम्रो लागि हो
लाइक त्यो फलो गर्यो भने चाहिँ आर वी सेफ
अहिले भने सबै अर्थक्वेक आयो अहिले एउटा अर्थक्वेक आयो अनि what is the age of that building I'm sorry मेरो नेटमा अलि समस्या आयो मैले क्वेशन सुनिन फेरि एकचोटी प्लिज
हैन मेरो पनि समस्या आयो जस्तो भयो जुन चाहिँ अहिले मापदण्ड बनाएको छ नि सरकारले त्यो मापदण्ड अनुसार चाहिँ सबै कम्युनिटीले फलो गर्यो भने आर वी सेफ ड्यू टु द स्ट्रक्चर अथवा स्ट्रक्चर कोल्याप्स देखि चाहिँ हामी सेफ हुन्छौं
एउटा कस्तो हुन्छ बिल्डिङ कोड भन्छ संसारभरि एउटा प्र्याक्टिस के छ भने बिल्डिङ कोड एउटा ठुलो अर्थक्वेक आएपछि बनाउँछ and it will work until there's a larger earthquake and then they will make a new one and it works until there's another big earthquake so हाम्रो पहिला अहिले भइरहेको कोड चाहिँ हामीले 45 सालको भैँचालो छ 1989 को earthquake भन्छ उदयपुरमा गएको भैँचालो त्यसको आधारमा बनाएको but that was only 6.5 and then now there was a 7.8 earthquake many buildings collapsed but still के भन्छौं हामी भने we were lucky very very lucky किनभने most of the energy it went to the north of Kathmandu मैले एउटा म्यापमा देखाएको थिएँ काठमाडौँको नर्थ तिर रेड म्यापमा so that's why Kathmandu was very lucky त्यो एरियामा बिल्डिङहरु धेरै थिएन had it been Kathmandu we don't know so only 19% buildings got damaged in all over the area that's very very less अब त्यत्रै अर्थक्वेक युएसमा अथवा क्यालिफोर्नियामा आइदिएको भए मेबी 3% बिल्डिङ्स मात्र ड्यामेज हुन्थ्यो होला, हामी कहाँ 19 भयो। जापानमा आयो भने 2% पनि ड्यामेज हुँदैन, बिकज दे हेभ भेरी भेरी स्ट्रङ बिल्डिङ कोड एन्ड दे आर रियली स्ट्रिक्ट अन द्याट। अब हामी कहाँ के हुन्छ, तपाईँहरू पनि अब हुनुहुन्छ होइन, बुझ्नुहुन्छ, तपाईँले वरिपरि घर बनाएको हेर्नुभयो भने 1 फिट बाई 1 फिटको पिलर लाउने भन्छ, अनि तपाईँको ठेकदारले भन्छ चाहिने 1 9 इन्चको नालीकन भने हुन्छ, के हुँदैन यत्रो घर बनाइसके कुनै पनि भत्केन भन्छ। अभियसली बिल्डिङ अर्थक्वेक नै यदि 100 वर्षमा एउटा आउँछ भने उसले बनाएको बिल्डिङ कसरी भत्किन्छ? सो that's a problem people have. And Rijan सरले भन्नुभयो जस्तै if we follow that rule we might be safe, much safer than what we were before. अब अहिले एउटा नयाँ बिल्डिङ कोड आइरहेछ, गभर्मेन्टले पारित गरिसकेको छ। सो it was prepared after 2015 Gorkha earthquake, so it is still the building constructed with that code in mind will be stronger than what we have already. So मैले ड्याडी मम्मीलाई भनेको, बुवा मालाई भनेको थिएँ, म उतै थिएँ, and then they were staying at this house, घरमा बस्नु भएको थियो, and recently नयाँ really अरूभन्दा अलि नयाँ बिल्डिङ भयो हाम्रो, and then my brother, he was really scared and he wanted to go out. Okay, like everybody was staying outside in the tent, and then he wanted to go out. And मैले के भने भने यदि हाम्रो घर त्यो भैँचालोमा भत्क्यो भने काठमाडौँको 70% घर बाँकी रहँदैन, because I know like the code were followed.
Okay.
एउटा कन्फिडेन्स छैन भने त you have to go to open space. अब काठमाडौँमा open space कहाँ पाउने? That's a real problem. Where do you find? There's no real open space now. त्यही भएर stringent measuresहरू अपनाउनु पर्ने हुन्छ। अघि भने जस्तो our structure kill us, not earthquake. So be careful. अब टेबल मुनि छिरेर घाम ढाक्ने भनेको त ठिकै छ, अब मेरो कोलुमै कोल्याप्स भएर माथिबाट मलाई स्ल्याबले थिच्यो भने त that's another thing. So there are many things about
तर एउटा कुरा चाहिँ यो चाहिँ अलिकति मान्छेहरूलाई नि कस्तो हुन्छ जस्तो लाग्छ भने आत्मबल पनि बढ्छ जस्तो लाग्छ कि, अनि यसलाई चाहिँ राम्रो लिएर गयो भने मान्छेले फलो पनि गर्छ। किनभने अहिले मलाई पनि अघि अब सुबेकको टक भन्दा अगाडिसम्म चाहिँ भुइँचालोले मलाई मार्छ भन्ने फिल भएको थियो है, त्यो सोचिनु क्या, सोसाइटीमै देखाएको सोच्छ नि त भुइँचालो आउने चाहिँ मरिन्छ भन्ने, तर भुइँचालो होइन स्ट्रक्चरले चाहिँ मरिन्छ अथवा स्ट्रक्चर नराम्रो हो, त्यो चाहिँ अवेरनेस हामीले कम्युनिटीमा पुर्यायौँ भने पनि निकै नै रहेछ कि क्याजुअलिटी सेफ हुने रहेछ।
किनकि भुइँचालो त नेचुरल हो।
Exactly, right? So if you are in a meadow, like घाँसे मैदानमा, it's a meadow, you are still in the middle of a meadow, and then you have an earthquake. Unless there's a real big earthquake which opens the earth and swallows you in like Sita in Ramayana, it won't kill you. And that's really improbable. त्यत्रो earthquake आउँदैन। Okay?
होइन यो पनि त च्यालेन्जको लागि चाहिँ भयो नि त, जस्तै यो नासा स्पेस एप च्यालेन्जमा हामीले चाहिँ अवेर गर्ने एप चाहिँ बनायो भने भइहाल्यो नि त, भयो नि त, कति राम्रो भयो, सिम्पल, कति मजाको भयो कि। अब मलाई त अहिलेसम्म थाहा छ यो नेचुरल फिनोमिना हो, तर यो समाजले चाहिँ के बनाइदिएको छ नि भुइँचालो आउने त्यो मरिन्छ भने त्यो भित्रीबाट आउँछ नि त्यो होइन, अथवा हल्लिन थाल्ने बित्तिकै चाहिँ गइन्छ भन्ने। तर मलाई त त्यो हुन्छ भने हामीहरू लगभग सबैलाई नै यो हुन्छ होला, सुबेक बाहेक अहिलेको अब मलाई पनि के हिम्मत चाहिँ आयो भने होइन रहेछ नि यो त होइन, अब रियलाइज भयो कि थाहा पाउनु र रियलाइजेसन हुनु धेरै नै।
Sorry, Rijan, I want to okay. I'm going to tell you a secret about me. Though I study earthquakes, मैले 6 भन्दा ठुलो earthquake feel गरेको छैन अहिलेसम्म। Because 45 सालको earthquake I was very small. I was 3 or 4 years. I didn't know that. अनि 2011 मा एउटा earthquake आएको थियो सिक्किममा, if you know that. I don't know how many of you know that. 2011 मा I was not here. I was in Rara. Field ma gate Muguma. I was not here. I didn't feel that. 2015 Gorkha earthquake. I was not here. I was in Japan. I came back. अनि 2015 को हाम्रो गोर्खा earthquake जाने बित्तिकै 12 गते भुइँचालो आयो, 16 गते म काठमाडौँ आएँ हैन, अनि म 28 गते फर्केँ, 29 गते फेरि भुइँचालो आयो। I didn't feel that. अनि त्यसपछि म जापानमै बसेँ, म स्टडी गरिरहेको थिएँ। 2016 मा जापानमा ठुलो earthquake आएको थियो। I was not in my college. म अर्कै फिल्डमा गएको थिएँ। अनि फर्किने साल 2018 मा पनि म बसेको सहरमा ठुलो भैँचालो आएको थियो 7.2 को. I was not there. I was somewhere in the south. So I haven't felt any earthquake till now. That's a secret about me. I don't know.
It's really interesting story. Earthquake लाई पनि डर लाग्यो होला नि त चाहिँ यहाँ
So that's an interesting thing.
Really nice, interesting.
यो 29 गतेको भैँचालो पछि अनि मैले फोन गरेको थिएँ भाइलाई and like 2-3 years younger than me, and then he was staying he was staying outside, and then I told him like earthquake keep any huँदैन, just go inside, just if you are really worried, stay in the ground floor. कोठा थियो अहिले बसिरहेको छु, you stay in the ground floor. अनि उले मलाई के भन्यो, अहिलेसम्म तपाईले भैँचालो कहिले फिल गर्नु भएको छ भनेर सोध्यो. Like no, and then said त्यसो भए के ठुलो कुरा गर्नु भएको त. So, and I was speechless. I didn't have to tell anything. I was like, okay, all right, then do as you like. Okay, so if you want, I can give a talk about earthquakes, given many aspects of earthquake. If you have time,
yeah,
time is not over. But a सानो talk पनि दिन्छु. Like this.
Subeg, यो हाम्रो यो कम्युनिटी अफ प्रब्लम सल्भर भन्ने एउटा चाहिँ हाई स्कुल स्टुडेन्ट्सहरुकै कम्युनिटी हो के. त्यसमा चाहिँ म चाहिँ एज अ मेन्टर भनौँ अथवा के भनौँ एज अ गाइड उनीहरूलाई चाहिँ ड्राइभ गर्नलाई चाहिँ अलिकति हेल्प गर्नलाई मात्र बस्या हो. र मन्थली अथवा ट्वाइस इन अ मन्थ हामीहरू टक राख्ने सोचमै छौँ. यो एक्जाम भइरहेको छ, त्यही भएर मन्थली नै ठिक हुन्छ जस्तो लाग्यो. मन्थली हुँदाखेरि अभियसली यो त एकदम इन्स्पायरिङ टक छ, एकदम इन्स्पायरिङ टक छ. यो अरूलाई पनि म बोलाउँछु होइन. अनि त्यो सबैको एक्जाम सिद्धेको बेला जब उनीहरू फ्री हुन्छ नि, फ्री माइन्डमा चाहिँ पक्कै पनि के बेनिफिट हुन्छ कि उनीहरूलाई यो टक.
एन्ड देन मैले किन भनेको भने हाई स्कुल स्टुडेन्ट्सहरूले नै हो आमा बुवालाई सम्झाउने पनि. दे विल लिसन टु यु. मैले गएर भने तपाईँको बुवा आमाले को मान्छे के भन्न आएको भने इफ यु टेल देम दे माइट लिसन टु यु. धेरै कुरा भन्नुपर्छ. मैले अघि इक्जाम्पल दिएको किनभने हाम्रै छिमेकीहरू दे वर कन्स्ट्रक्टिङ बिल्डिङ एन्ड देन दे वर नट फलोइङ द कोड. And then I asked them, and he said, 80 वर्षमा त भैँचालो आउँछ, यो घर 70 वर्षको भन्छ. अब के भन्ने अब? मैले त्यस्तो हुँदैन, अर्को यसरी आउँदैन भनेको. अब 90 मा आयो, 72 मा आयो, अब अर्को 21 कतिमा आउँछ अब अनि भन्ने कुरा गर्ने. So that's not. We don't know when the earthquake will come. We always have to be ready. अब हामीले कति कुरामा तपाईले भन्नु होला हैन, भोलि अब आकृतिले नि भन्नु होला नेपालमा कति आउँछ, भैँचालो पनि यही आउँछ, फ्लड पनि यही आउँछ हैन, पहिरो पनि यही आउँछ, कोरोना पनि यही आउँछ. No, there are countries which are much worse than us. I'll give you an example. Have you heard the name of the country Indonesia? They have volcano, they have typhoon, cyclone भनौँ हैन, typhoon भन्छ. They have earthquake, they have tsunami, they have landslide, they have flood. You name them, they have that disaster. And they talk about Japan, they have volcano, and they have volcano. They get a lot of earthquakes. Something earthquake गइरहन्छ. अब जस्तै फर एक्जाम्पल हामी यसरी अफिसमा बसेका छौँ, 5 को earthquake गयो भने you all will get up. भैँचालो भन्दा 5.5, 6 सम्मकोमा Japanese they don't get up. They are confident of their building, and it's so common. 6 को भैँचालो is so common, sir. They won't even get up from their bench. And then we like get up. Is that earthquake? And then they will say hi. Hi means yes in Japanese. Hi. Yes. Okay. And then I have to sit down because nobody moved. So they have the typhoon, and they have landslide, they have flood. Japaneseहरूको terrain अझ हामीभन्दा fragile छ किनभने त्यो volcanoले develop गरेको landslide areasहरू चाहिँ हामी भन्दा पनि fragile हुन्छ. हामी कहाँ त rock छ at least. They don't even have rock. They have like kind of soil. अनि सानो पहाडहरू छ उनीहरूको. त्यही भएर हाम्रो जस्तो ठुलो ल्यान्डस्लाइड जाँदैन. They have landslides. अनि जापानिजहरूको लागि हामी डाँडामा माथि बस्छौँ. जापानिजहरू तल पिँधमा बस्छ. हामी के भन्छौँ बेसीतिर बस्छ प्राय. अनि ल्यान्डस्लाइड आउँदाखेरि उनीहरूको पुरा. So there are countries that are worse than us. त्यो एउटा चाहिँ सम्झिनुस्. कसैले तपाईलाई नेपालमा यस्तो त्यस्तो भयो भने होइन. Just a natural phenomenon. It happens. Okay. That was really interesting to talk with you. Any other questions? Any questions?
And thank you so much, sir, for giving your precious time as a course to interesting session, knowing about earthquakes, flood, landslide.
Thank you.
Yes, sir. Thank you very much for today's
Very
session.
thankful, sir. Yes, sir. Very much
Yes,
thankful.
sir.
I'm sure that everyone enjoyed it as much as I did. Yes, sir.
And if you have any questions, you can just mail me, or you can contact me through Rajendra sir.
Okay, sir. We will surely contact you when any question arises that is related to earthquake and geology. Yes, sir.
And I might answer a little later. Maybe a little busy. I'm very early. So online exam college go. So it's a board examination from tomorrow, and we might get a little busy. But still, I'll try to answer that. Then maybe 1 or 2 days late, but I will surely answer that. Thank you. Thank you very much for giving me the opportunity.
Thank you.
Okay. Subeg, so अब चाहिँ आएर म साथी तरिकाले कुरा गर्छु किनभने एउटा टक सिद्धिसक्यो हैन तर साह्रै नै रमाइलो थियो आई एम रियली थ्याङ्कफुल हैन समय कति व्यस्त थियो सुबेग हुँदै पनि यु एक्सेप्टेड र हाई स्कुल स्टुडेन्ट्सको लागि भनेर जुन चाहिँ इन्ट्रेस्ट देखायो सो अझै पनि अरू हाई स्कुल स्टुडेन्ट्सहरूलाई हामी इन्क्लुड गर्नले वातावरण बनाउँछौँ हैन उनीहरूको एक्जाम सिद्धिएको पछि अनि सबैको पनि टाइम फ्री भए पछाडि जस्तै त्यो म्याच गराएर कुनै एउटा किनभने यो टक चाहिँ साँच्चै नै एकदमै के भन्ने कि एकदमै इन्साइटफुल अनि चाहिने टक पनि हो कि ठ्याक्कै नेपाली कम्युनिटीलाई चाहिने र हाई स्कुल स्टुडेन्ट्सले जाने भने पक्कै पनि प्यारेन्ट्ससम्म पुर्याउँछ त्यो चाहिँ हो and thank you so much Subeg, thank you
thank you for giving me the opportunity.
Okay, thank
you everybody. Thank you very much and stay safe. All right, so best of luck for your future. Thank you very much. Thank you, ma'am.
Okay.
Thank you.
Bye bye.
By the way,